Okay, we're in chapter 3, which is all about graphing and slope, aka rates of change. So in the 17th century, which is about the 1600s, René Descartes, a French mathematician and philosopher, used a horizontal and vertical number line to divide the plane into 4 regions called quadrants. It says a plane set up according to Descartes' system is known as, should really say, the Cartesian coordinate plane. It says the horizontal line is called the x-axis, and the numbers on this axis are called x-coordinates. And the vertical line is called the y-axis, and the numbers are y-coordinates. The ordered pair 0, 0 is called the origin. Okay, so let's look at that on the graph. We have quadrants. This is called quadrant 1, quadrant 2. These are Roman numerals. Quadrant 3, and quadrant 4. V is a 5. If there's a 1 to the left, it's a removal of 1. So 5 minus 1, 4. This is the x-axis. This is the y-axis. These are x-coordinates. These are y-coordinates, okay? 0, 0 is the origin. It says on the following coordinate plane above, graph the following coordinates. So 2, 4. So 2 on the x-axis, 4 on the y. So you're going to go from the origin, 1, 2, and then on the y-axis, up 4. 1, 2, 3, 4. Make a dot. Part B, okay, or letter B, -1, 3. So you're going to go, here's your origin, -1 up 3. 1, 2, 3. So we could say this is A, this is B. C is -3. So on the origin, go to -3 for the x, -5 for the y, and this is C. D is 4, -2, put a dot. That is D. All right, now they're saying, here are some coordinates. Can you write down what they are? So if I start at the origin, A is over 1, 2, 3, and up 2. Over 1, 2, 3, and up 2. B, starting from the origin, is to the left 1, 2, 3. So to the left 3 and down, it looks like -5. C, you're going to the left 1 and up 3. So left is negative, up is 3. And D, you're starting in the origin, you're going right 6 and up 0. Questions? Feel free to please ask. Okay, next page. It says, where do these coordinates come from? Okay, most of the time ordered pairs are extracted from equations. Look at the expression 2x plus 1. Okay, if we substitute a -1 in for x, then what is our output or answer? If I put -1 in, I get -2 plus 1, which ends up being 0. I'm sorry, no, it doesn't. -2 plus 1 is -1. Sorry, I was thinking. Okay, if I substitute in a 0, 2 times 0 is 0 plus 1 is 1. 2 times 1 plus 1 is 3. So what I'm doing here is I'm telling you what your x value is. You substitute that into your expression. You simplify it, and that is your output. It says x is called our input, which is our domain. It's what we're allowed to put into our expression. It is our independent variable. We get to decide what goes in. But y is called not our input, but our output. It is not our domain, but our range. And it's our dependent variable because it depends on what we input. Okay, so these outputs are also called y. Whatever came out from this expression we call y, therefore we can write our expression as an equation. Okay. Make a table for the equation y equals 3x minus 1. We're going to have our inputs x and then receive our outputs y. We're going to put in -2, -1, 0, 1, 2, and 3. I'm giving you some positives, some negatives, and zeros. So if I substitute each value in, what's going to come out? I'm going to substitute a -3 and I'll get -7. I'm going to substitute in -1 to get -3 minus 1 is a -4. I'm going to substitute in 0 to receive -1. 3 times 1 minus 1 is a 2. 3 times 2, 6, minus 1 is a 5. And 3 times 3 minus 1 is an 8. So this is my coordinate, -2, -7. It says graph the ordered pairs on the coordinate plane and connect the points to make a line. A linear pattern is said to exist when the points examined form a straight line. So I'm going to go to -2 and go to -7, which is a little bit off our paper, but we can manage. -1, -4. -1, -4. 0, -1. 1, 2. 2, 5. 3, 8. Okay, connect. Yep, it is a linear pattern. Okay, on this side, you are going to complete this worksheet. It says, how does the average man feel today? Complete the table of solutions for each equation. Graph the solutions and draw a line through them. If extended, the line will cross a letter. If this letter in each box contains the exercise number. All right, so if I plug a 3 in here, that becomes a 9 minus a 2, which is 7. Now, some of you can do that in your head, but some of you need a calculator. So let's grab one. And so what you could do here is, if I'm plugging 3 into here, I would say 3, not x, we're replacing x with 3, minus 2. That would give us 7. 3 times 2 minus 2 is going to be 4. And then substitute in -2. 3 times -2 minus 2 is -8. 3 times 0 minus 2 is -2. So then you're going to go ahead and graph. You're going to go to 3, 1, 2, 3, and then up 7. 1, 2, 3, 4, 5, 6, 7. Okay, 3, 7. Here, 2, 4. 1, 2, 1, 2, 3, 4. Okay, at -2, -8. So -2, 1, 2, -8, 1, 2, 3, 4, 5, 6, 7, 8. Are we in a linear pattern? If we're not, something's wrong. And then 0, -2. Okay, then we're going to grab a ruler. We're going to connect our dots. And we go through the letter T, not K. So wherever we see the number 1, we're going to put a T. Okay. Let's try it again. Number 2, same thing. You can put -2 times, not x, but 5 now, plus 5 is -5. -2 times -1 plus 5 is 7. -2 times 2 plus 5 is 1. And like I said, you don't have to do this, but if you just want to be careful or be sure or check your work, you can. So then you go to 5, 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, make a dot, -1, -1, and then positive 7, 1, 2, 3, 4, 5, 6, 7, and then 2, 1, so start at the origin, 1, 2, 1, and then 0, 5, 0, 1, 2, 3, 4, 5. Okay, so we're going to connect the dots. And you go through odd. that I or L? Let's look. I think that's an I. So for number 2, wherever you see a 2, you're going to put I. Okay. And then you're going to keep doing this until you fill it all out. Okay. You'll know if you did it right if there is a straight line. You know you did it right if you touch a letter. If you do not, something's off.